Hi, now let us move to the third question. What is the third question? If f of x equal to kx e raised to minus x, x greater than 0, equal to 0, elsewhere is a PDF of random variable x, we have to find the value of k. So, to find k, we can already use the equation. In continuous case, we have the equation integral minus infinity to infinity, f of x dx is equal to 1. So, just substitute the value in the place of f of x. Okay? I think you can follow that. And you have got this. Here we have only the limit from 0 to infinity because in the less than 0 or greater than or equal to 0, the function is given 0 elsewhere. So no need of looking for that. Just look only greater than 0. So integral 0 to infinity, kx e raised to minus dx equal to 1. Now, what is the next step is you have taken the k outside. Okay, that is x into e raised to minus. Now, you have to do integration. So the first one is x. You have to do this with integration with parts, right? So x into e raised to minus x, x into integral of e raised to minus x. What it is? E raised to minus x divided by minus 1 minus. We will be having derivative of first function. Derivative of first function is x, right? So 1 into integral of second function. So e raised to minus x minus 1 plus c. This will be the integration. So you will be doing this. So we have got the limit 0 to infinity equal to 1. So here when we are substituting, first we will be putting e raised to infinity. That will become the whole term will become 0. In the both cases it becomes 0. And when we are substituting 0, what happens is first term will become 0, but the next term, this one will become minus e raised to 0 means 1. So minus of minus 1. So k is equal to 1. So we got the value of k. K is equal to 1. Okay, that was the question there. So we can just rewrite the function as what it is written here. How it is rewritten? Can you please say? Yes, it is instead of k, you have put there. Okay, I think it's clear for you. Any doubts over there? Any doubts? You may ask me. Okay. Now let us look the fourth question. What is given in the fourth question? Find the value of k so that the following is probability density function of random variable f of x equal to 0 if x less than or equal to 0 and kx e raised to minus 4x square x greater than 0. Now, look at the first one. It has some limits, right? That is difference. From 0 to infinity, it is some value and from minus infinity to 0, it is some other value. So we have just split it into two. Doesn't mean to split it. If you don't split it also, it is not, it's okay because in the remaining terms, the function value is 0, right? So just substitute it. But here there is some difference that I will explain because here the function is somewhat different, right? It is x into e raised to minus 4x. We cannot integrate it easily. So for that, we will be putting a substitution. You have already studied the substitution method. For that, what you are going to do is you will just substitute this 4x square. You will be substituting 4x square is equal to u. Okay. That is 4x square is equal to u. From there, what you can do, look this step 4x square. So 4x square means when you are differentiating on both sides, what you get 8x dx equal to du. So that you can write that x dx as du by 8. Okay. Now you could substitute it here. Okay. Any doubts you may ask me. Okay. Okay, you can substitute there and just find the value. Okay, I'm not explaining this the easiest step, so it's okay to understand. If you have doubts, you may ask me. Okay, I'm not just explaining all the steps. What the thing is that you have substituted 4x square is equal to you have substituted, changed the limits accordingly. After that, what you have done is in the last step, you will be just substituting it. That is replacing after integrating that. After that, you will be changing the limits and fine. You will get the answer k equal to 8. I think it's clear for you. If you have any doubt, you may ask. Okay. Next, let us move to the next question. That is the fifth one. Find the value of b so that the following function is valid. PDF is given. We have to find CDF, that is cumulative distribution function, and also p of x greater than or equal to f of x. For that, for doing that, what we have to know first is you have to find the value of b, right? This limit is not given. So first find the value of b. For that, what you will do, you know the basic equation. What is the equation? Integral minus infinity to infinity f of x dx is equal to 1. Substitute it. Integral 0 to b 2x dx. We will be getting b equal to plus or minus 1. But we cannot take negative because the value will be always only greater than 0, right? So no negative. So only b equal to 1 is possible. Okay, now you want to find the CDF, that is cumulative distribution function. of this continuous random variable. That is also important. So what you are going to do is you will just draw a line like this. I think you can see that minus infinity to 0, 1 to infinity. Why we took like this? Because the thing is that the limit is from 0 to 1, right? B is 1, so 0 to 1. So it will be less than 0, greater than 1. That's case is considered here. First is capital F of x equal to integral minus infinity to x f of x dx. That is our main idea. Case 1 is x less than 0. What about x less than 0? Function value is always 0. So the function is, what about x 0 less than or equal to x less than 1? Which means the function value is still not reaching 1 because it is less than or 1 only. So it is up to x. So when you do this, you will be getting x square. So integral minus infinity to 0 f of x dx plus 0 to x f of x square. What about case 3? Case 3 means it is, you can look this line, okay? It's x greater than or equal to 1. In that case, you will be getting the value 1. So how can you write this? This can be written as capital F of x is equal to 0. That is f of x equal to 0. This can be replaced by capital F of x, okay? It's written as small, but it is capital, okay? Capital F of x equal to 0 if is x less than 0, x square if x 0 less than or equal to x less than 1, and 1 if x greater than or equal to 1. I think it's clear. I don't think you will have any doubt. If you have any doubt, you may ask me. Okay, now you have one more thing to find this. What is it? P of x greater than or equal to 0 0.5. For that, what you will do, integral 0 to infinity, 0 0.5 to infinity, f of x dx. That is small f of x. Don't mix up with the capital F of x. That is small f of x. Here is also 0 0.5 to infinity, the question like that. But you have to split the limit. Why? Because if it is coming from 0 0.5 to infinity, the whole limit is taken. But we cannot take like that because there is a split in between, right? The function value from 0 to 1 is 1 and the other rest of the values are different. So you have to split the limit. That is 0 0.5 to 1, we are having a value. And above 1 to infinity, you don't have a value. So you just cancel that and find the answer. Okay, just simple integration only. If you have any doubt, you may please contact me. Okay, thank you.